So for this next one, we have to prove that the sum of 1 over j times j plus 1 from j equals 1 to n equals n over n plus 1. So our first step, n equals 1. So now we don't just have that, we have to plug into this to get our first term. So we plug in 1, we get 1 over 1 times 1 plus 1 equals 1 over 1 plus 1. So that's 1/2 equals 1/2. Then for n equals 2, we do 1/2 plus 1 over, now we're plugging into this one, 2 times 2 plus 1 equals, plug into that, 2 over 2 plus 1. So you get 1/2 plus, this will be 3 times 2 is 1/6 equals 2/3. Now a half plus a sixth, that's 3. Same thing as multiplying by 3 over 3. So you get 3 over 6 plus 1 over 6 is 4 over 6, which reduces 2 over 3. So you have 2 over 3 equals 2 over 3. So now step 2, do n equals k. So you have 1/2 plus 1/6 plus dot 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 plus 1 over k times k plus 1 equals k over k plus 1. So now for step 3, you have n equals k plus 1. So now you take this, k over k plus 1, plus, plug in k plus 1 here. So you have 1 over k plus 1 times k plus 1 plus 1, which is just k plus 2, equals, now we're plugging k plus 1 to there, so k plus 1 over k plus 1 plus 1, which is k plus 2. So now we're going to want to combine these, so we're going to multiply this fraction by k plus 2 over k plus 2. So we're going to have k times k plus 2 plus 1 over k plus 1 times k plus 2 equals k plus 1 over k plus 2. So now if we multiply that out, we have k squared plus 2k plus 1 over k plus 1 times k plus 2 equals k plus 1 over k plus 2. So now this breaks back up into k plus 1 times k plus 1. So we have k squared plus k, which is plus 2k plus 1 over k plus 1 times k plus 2 equals k plus 1 over k plus 2. And now these would cancel out, so you have k plus 1 over k plus 2 equals k plus 1 over k plus 2.